On a spring morning in 1887, two physicists named Albert Michelson and Edward Morley set up an experiment in a basement laboratory in Cleveland, Ohio. They were trying to measure something that everyone at the time believed existed. Something invisible that filled all of space. Something that carried light, the way water carries waves or air carries sound. They called it the luminiferous ether. The experiment was meticulous. They sent beams of light in perpendicular directions and measured whether Earth's motion through this cosmic medium affected the light's speed. The logic was simple. If you swim with a current, you move faster. If you swim against it, you move slower. Light should behave the same way moving through the ether. The experiment found nothing. No difference in light speed in any direction. Not a whisper of variation. The result was so unexpected that they repeated the experiment, then again, then dozens more times over the following decades. Always the same answer. Light travelled at exactly the same speed, regardless of Earth's motion. This wasn't just surprising. This was impossible according to everything physics understood about how the universe worked. But here's what makes this moment so quietly devastating. The experiment didn't just fail to find the ether. It revealed something far stranger, something that would force a complete reconstruction of how we think about space, time, motion, and reality itself. Most people, when they hear that nothing can travel faster than light, accept it as a brute fact, a cosmic speed limit imposed by some mysterious physical law. They imagine it like a car that simply can't go beyond a certain velocity, no matter how much gas you give it. But wait, that's not actually what's happening. The speed of light isn't a limit in the way you might think. It's not that we haven't built a powerful enough engine. It's not that we lack the energy. The reason nothing with mass can reach light speed is far more profound and far more unsettling than a simple barrier. To understand why, we need to understand what light actually is, not just electromagnetic radiation, not just photons bouncing around, but what light represents in the fundamental structure of reality. Think about this carefully. When we say light travels at 299,792,458 meters per second, we're not just describing how fast something moves. We're describing a property of space-time itself. The number isn't arbitrary. It's not that light happens to travel at this speed, it's that this speed is woven into the geometric fabric of the universe. Let's start with something simpler, something more familiar. Imagine you're standing on a train platform, watching a train pass by at 100 meters per second. Someone on that train throws a ball forward at 20 meters per second relative to the train. From your perspective on the platform, how fast is the ball moving? Your intuition says 120 meters per second, the train's speed plus the ball's speed. This is how velocities add in our everyday experience. It's what Isaac Newton described in his laws of motion. It's what makes perfect sense if you've lived your entire life at human speeds. Now imagine the same scenario, but instead of throwing a ball, someone on the train turns on a flashlight. The light beam travels at 299,792,458 meters per second relative to the train. You're standing on the platform. The train is moving. How fast should you measure that light beam to be moving? According to classical physics, according to Newton, according to common sense, you should measure it moving faster than 299,792,458 meters per second. The train's speed plus the light's speed, but you don't. You measure it moving at exactly 299,792,458 meters per second. The same speed, no addition, no difference. This isn't a measurement error. This is verified to extraordinary precision. Every observer, regardless of their motion, measures light travelling at exactly the same speed. This is what's really happening, and this is where your intuition about reality begins to crack. The constancy of light's speed across all reference frames means something impossible is true. It means that space and time themselves must be adjusting to preserve this constancy. Think about what this implies. If you're on that train and you measure light at speed c, and I'm on the platform and I also measure it at speed c, then our measurements of space and time cannot be the same. One of us must be experiencing space differently. One of us must be experiencing time differently. Or both of us are experiencing both differently. The universe is literally reshaping distance and duration to ensure light's speed remains constant for all observers. This is what Einstein realized in 1905, not that light had some special property that made it fast, but that the universe has a structure where there exists a maximum speed of causality, a speed at which information can propagate through space-time. Light doesn't travel at this speed because it's special. Light travels at this speed because light has no mass, and anything with no mass must travel at exactly this speed, always. It cannot go slower. It cannot go faster. The speed limit isn't placed on light. Light is the manifestation of the speed limit. But wait. What does this have to do with why you can't accelerate a rocket or a particle past the speed of light? Here's where it gets truly strange. To understand this, you need to grasp something deeply counterintuitive about motion through space-time. You are right now moving through space-time at the speed of light, not through space. Through space-time. Every object in the universe is always traveling through the four-dimensional fabric of space-time at exactly the speed of light. Always. You, me, this planet, every atom. The difference between a stationary object and a moving object is not whether they're traveling through space-time, but how their motion through space-time is divided between the spatial dimensions and the time dimension. When you're sitting still, all of your motion through space-time is directed through the time dimension. You're moving through time at maximum speed, 1 second per second. But when you start moving through space, some of your motion through space-time gets redirected from the time dimension into spatial dimensions. The faster you move through space, the slower you move through time. This is time dilation. This is why moving clocks run slow. This is why astronauts age slightly less than people on Earth. Not because of some mysterious force acting on clocks, but because their motion through space-time is divided differently. Now here's the critical insight. If all your motion through space-time is already at the speed of light, and you redirect more and more of that motion into spatial dimensions by accelerating, you approach a limit. That limit is when all of your motion through space-time is redirected into spatial dimensions, and none remains for temporal motion. At that point, you would be moving through space at the speed of light, and through time, not at all. Time would stop for you. And here's the thing, you can't redirect more than 100% of your motion. You can't move faster through space-time than the speed of light, because you're already moving through space-time at the speed of light. There's nowhere to go beyond that. This is what's really happening when physicists say nothing with mass can reach light speed. It's not that the energy requirement becomes infinite, though it does. It's not that your mass increases relativistically, though that's one way to describe it. It's that you're trying to redirect more motion than you have. You're trying to go faster than you're already going through space-time. It's geometrically impossible. Think of it this way. Imagine you're driving a car where the speedometer always reads exactly 60 miles per hour. Not approximately. Exactly, no matter what you do. If you're driving north at 60 miles per hour, you're not moving east or west at all. If you turn and start driving northeast, you're now moving north at about 42 miles per hour and east at about 42 miles per hour. Your total speed is still 60. If you turn completely east, you're moving east at 60 miles per hour and north at 0. But in no direction can you ever exceed 60 miles per hour because your total speed is always 60. You can only redistribute which directions that speed goes. That's motion through space-time. The speedometer always reads the. You can only change how much of that c goes through time and how much goes through the spatial dimensions. Light, being massless, has no choice in the matter. All of its motion is through space and none through time. From light's perspective, if such a perspective existed, no time passes. A photon emitted from a distant star and absorbed by your eye has experienced zero time between emission and absorption, even though billions of years might have passed in our reference frame. The journey is instantaneous from the photon's perspective because it has no motion through time at all. This is why faster than light travel would violate causality. If you could move faster than light, you could move backward through time in some reference frames. You could arrive before you left. Effects could precede causes. The logical structure of reality would collapse. The universe doesn't just forbid this with a law. The universe is structured such that it's geometrically impossible. But here's what makes this explanation so unsettling. It means the speed of light isn't really about light at all. It's about the structure of space-time. It's about the relationship between space and time. It's about the geometric limitations of a four-dimensional universe where these four dimensions are interwoven in a specific way. The speed of light is really the speed of causality. It's the speed at which one event can influence another. It's the maximum rate at which information, in the broadest physical sense, can propagate through the universe. When Einstein first worked this out, he realized something remarkable. The math didn't care about what was moving at this ultimate speed. The equations just said that there existed a fundamental speed constant in the universe. A speed that was the same for all observers. A speed that represented the exchange rate between space and time. Only later did physicists confirm that this fundamental constant was exactly equal to the speed of light. The two were always the same thing. Light was simply the most obvious messenger of this deeper truth. There's an even deeper layer here. Why does space-time have this structure at all? Why is there a speed limit? Why does the universe work this way? These questions push us toward the boundaries of current physics. Some theories suggest it relates to the quantum structure of space-time itself. That at the smallest scales, space and time aren't continuous but discrete. That the speed of light might emerge from the granularity of space-time, the way the speed of sound emerges from the properties of the medium carrying it. Other approaches suggest the constancy of light's speed is connected to fundamental symmetries in the laws of physics. That the universe could not be logically consistent if this speed weren't constant. What we know for certain is this. Every experiment ever conducted confirms it. Particle accelerators push electrons and protons to 99.9999% of light speed. They never reach it. They can't. The energy required grows without bound as you approach c, not because of engineering limitations, but because the geometry of space-time doesn't permit it. The particles' effective inertia increases toward infinity as they approach light speed. Not because their mass truly increases in the classical sense, but because the relationship between energy and momentum changes as more of the particles' motion through space-time gets redirected into spatial dimensions. This was verified with extraordinary precision in 1964 by physicist William Bartolozzi. He accelerated electrons to higher and higher energies and measured their speeds. As the energy increased, the speed increased. But not linearly. The speed approached light speed but never reached it. The electrons gained energy that went into effective mass rather than velocity. The experiment demonstrated viscerally that the speed of light isn't a technological barrier, but a structural feature of reality. Consider what this means for practical applications. GPS satellites must account for both special and general relativistic effects to maintain accuracy. The satellites move fast enough relative to Earth's surface that time dilation becomes measurable. Their clocks tick slightly slower than clocks on the ground due to their velocity. But they're also in a weaker gravitational field, which makes their clocks tick slightly faster due to gravitational time dilation. Both effects must be calculated and corrected. Without relativity, GPS would drift by kilometers per day. The technology in your pocket depends on the strange geometry of space-time. Particle physics is entirely built on relativistic principles. The Standard Model, our most successful theory of fundamental particles and forces, incorporates relativity at its core. When particles collide at high energies in accelerators like the Large Hadron Collider, they're moving at 99.9999991% of light speed. At these speeds, classical physics fails catastrophically. Only relativistic mechanics correctly predicts what happens, and every prediction aligns with observation. The universe is relativistic all the way down. But here's what truly humbles us. For all our understanding, we still don't know why space-time has the dimensionality it does. We don't know why time is one dimension and space is three. We don't know why the speed of light has the specific value it has, or whether that value is truly constant across all of cosmic history. These remain open questions. The speed of light connects to the deepest mysteries of physics. Why does the universe have laws at all? Why are these laws mathematical? Why is there something rather than nothing? What we've discovered is that the speed limit isn't imposed from outside. It's intrinsic to the structure of existence itself. Space and time aren't separate containers where events happen. They're aspects of a single geometric entity that has specific properties. The speed of light is one of those properties. As fundamental as the number of spatial dimensions, as basic as the forward flow of time, this changes everything about how we view reality. We don't live in a universe where space is a stage and time is a clock and objects move around according to simple addition of velocities. We live in a universe where space and time are interwoven, where motion redistributes itself between dimensions, where causality has a maximum speed, and where the fabric of reality itself ensures that this speed remains constant for all observers. The speed of light isn't a speed limit placed on motion. It's the revelation of space-time's geometry. When you understand this, really understand it, you realize that asking, why can't we go faster than light, is like asking, why can't we move in a direction perpendicular to all three spatial dimensions? The question misunderstands the structure of the space we're asking about. There is no faster than light within the geometry of our space-time. The concept is meaningless in the same way that a fifth spatial direction is meaningless. Not forbidden, not impossible because of some law, but geometrically incoherent given the structure of the universe we inhabit. This is the insight that Einstein and later physicists like Richard Feynman helped us grasp. Feynman, in his lectures, emphasized that the strangest aspect of physics isn't that it contradicts common sense. It's that common sense was built from limited experience at slow speeds and small scales. When we extend our observations to high velocities or cosmic distances, we discover the actual structure underlying reality. And that structure is stranger and more elegant than anything we initially imagined. The speed of light stands as a testament to this strangeness, not a barrier keeping us from the stars, not a frustrating limitation on cosmic exploration, but a window into the true nature of space, time, and existence. A constant that reveals the universe is not what it appears to be. That reality is far more subtle, far more interconnected, far more geometric than our everyday experience suggests. We cannot break the speed of light because we are always moving at the speed of light through space-time. We cannot exceed it because it is not a velocity in the traditional sense, but a conversion factor between space and time. We cannot surpass it because causality itself is woven into its constancy. To break the speed of light would not be to go faster. It would be to exist outside the geometric structure of space-time entirely. And that is why light speed can never be broken. Not because the universe forbids it with a law, but because the universe is structured such that the question itself doesn't quite make sense. The speed of light is not a limit imposed on reality. It is reality revealing its fundamental architecture. And we, moving through space-time at this cosmic constant, are part of that architecture. Always have been. Always will be. Understanding this doesn't diminish us. It elevates us to glimpse the true fabric of existence. The speed of light is the universe's way of telling us that space and time are not what we thought. That motion is redistribution, that everything is geometry, that we live in a cosmos far stranger and more beautiful than we ever imagined.